Good morning. My name is Dhruti Pithadia. I am lecturer in our university. Today's my topic is environmental effect on microbial growth or bacterial growth. Okay. Then what is microbial growth, bacterial growth? In this topic, what is microbial growth? Microbial growth, that means कि cells which increase in the number, not in the size. Okay. Environmental effect on microbial growth. What is which parameter which affect the microbial growth? Temperature, pH and osmotic pressure. First of all, temperature. All the microorganisms which grow at limited temperature range, that is known as cardinal temperature. There is three types: minimum, optimum and maximum temperature. Temperature is a major environmental factor which controlling the microbial growth. Okay. Then how the temperature affect on the microbial growth? Microbial growth occur by the metabolic activity which is occur into the cells, and metabolic activity that is not possible without the enzymes, and all the enzymes are temperature sensitive. If we provide the high temperature, then the enzymes will be denatured, because enzymes which mainly made up of the protein. Okay. There is a graph of the growth against the temperature. There is a three temperature: minimum, optimum and maximum. At the lowest minimum temperature, microorganisms microbial growth will occur. Membrane gelling, transport process so slow that the growth cannot occur. Microorganisms growth will occur but not at the highest rate. When we provide the higher temperature, then the enzymatic reactions occurring at increasing rapid rates, that is known as optimum. At the optimum temperature, enzymatic reaction occurring at the maximum possible rate. Maximum temperature, at the maximum temperature the protein will be denatured. Okay. Then minimum temperature, at the lowest temperature at which the microorganisms will grow. Optimum temperature, the temperature at which the growth will be occur at the fastest rate. Maximum temperature, the temperature at which the microorganisms will grow. The temperature classes of microorganisms: psychophile, mesophile, thermophile and hypothermophile. Psychophile, 0 to 20 degrees Celsius. In between this temperature range, microorganisms will grow, that is known as psychophile. Psychophile temperature range, that is 0 to 20 degrees Celsius. Cold temperature optima, that means at the lowest temperature microorganisms growth that is very high, that is optimum temperature. Most active representative inhabited permanently cold environment. Mesophile, the temperature range that is 20 to 45 degrees Celsius. Mid-range temperature optima found in warm-blooded animals and in terrestrial and aquatic environment in the temperate and tropical latitudes. Thermophile, the temperature range is 50 to 18 degrees Celsius. Growth temperature optimum between the 50 to 18 degrees Celsius, or we can say 45 to 18 degrees Celsius. Hypothermophiles, optima greater than the above 80 degrees Celsius, and this organism inhabited hot environment including the boiling hot springs as well as undersea hypothermal vents that can have the temperature excess the 100 degrees Celsius. Classification, there is a graph, growth rate against the temperature. You can see in the graph, first one graph, that is psychophile, and the psychophile organisms they can grow at the 0 to 20 degrees Celsius, but the optimum temperature that is 4 degrees Celsius. That means at 0 degrees Celsius and at 20 degrees Celsius microorganisms growth will occur, but at the 4 degrees Celsius microorganisms growth will be fastest. Second one graph, that is mesophile, that is example is E. coli, 20 to 50 degrees Celsius, that is the temperature range of mesophile, but at the 39 degrees Celsius microorganisms growth will be fastest. Thermophile, that is 40 to 80 degrees Celsius and 60 degrees Celsius microorganisms growth will be fastest. Hyperthermophiles, 80 degrees Celsius microorganisms growth will be fastest, and hyperthermophiles 106 degrees Celsius microorganisms growth will be 106 degrees Celsius will be fastest. Then next parameter, that is pH and microbial growth. pH, that means the concentration of H plus which is present into the cells. That is the pH which measure the H plus concentration is present in our cell. Each organism has a pH range and has a pH optimum. We can see in the temperature metabolic activity that do not occur without the help of the enzymes, and enzymes are sensitive to the temperature as well as enzyme it's also very sensitive to the pH. According to pH, there is a two type, acidophile and alkalophile. In the acidophile, optimum temperature, optimum pH range, that is 1 to 4, and in alkalophiles optimum pH range, that is 8.5 to 11. Here example, lactic acid bacteria 4 to 7 pH, thiobacillus thiooxidans 2.2 to 2.8, and fungi, that is 4 to 6. When the cells, the microbial organisms that is occur into the cells, right, and internal pH that is regulated by buffer. Buffer is a substance that cannot change, that cannot occur the change into the pH, and buffer near to neutral adjusts with the ion pumps. Human blood and human tissue pH, that is 7.2 to plus 0.2 variation, that means plus 7.2 to 7.4. The acidity or alkalinity of environment can greatly affect the microbial growth. Most microorganisms grow best at pH 6 to pH 8, between pH 6 to pH 8, but some microorganisms have evolved to grow best at low and high pH. Acidophile organisms that grow best at low pH, example Helicobacter pylori and thiobacillus thiooxidans. Alkalophily, example of alkalophily, Vibrio cholera and microorganisms grow best at high pH. Most of the pathogenic microorganisms that grow at a neutral pH, it is known as neutrophile. According to pH, there is three types: alkalophile, acidophile and neutrophile. There is a pH scale 0 to 7, that is acidity, and 7 to 14, that is basicity, and at the 7, that is neutral. If the microorganisms growth best at 0 to 7, it is known as acidophile, and 7 to 14 it is known as alkalophile, and at the 7 microorganisms growth will be fasted, is it known as neutrophile. Then third parameter, that is osmotic effect. First of all, what is osmotic effect on the microbial growth? We should know about what is osmotic pressure and what is osmosis. What is osmotic pressure? Osmotic pressure is the minimum pressure which needs to be applied to a solution to prevent the inward flow of water across the semi-permeable membrane. It is also defined the measure of the tendency of a solution to take in water, that is known as by osmosis. Clear what is osmotic pressure and osmosis? Okay. Osmotic pressure depends on the surrounding solute concentration and water availability. You know very well what is the solute concentration, but what is water availability? Water availability, that is vapor pressure of the solute divided by vapor pressure of the water. Let's see the definition of the water availability, or we can say water activity. The symbol of water activity or water availability, that is small a and W. Water activity is the ratio of the vapor pressure of air in the equilibrium with substance or solution to the vapor pressure of the pure water, and always the pure water vapor pressure that is equal to the 0. See the equation, water activity or water availability is equal to vapor pressure of the solution divided by vapor pressure of the water. Okay. When a microbial cell is in the solution whose concentration of the solute is higher than in the cell, and the cellular water passes out and the cellular water passes out through the plasma membrane to a high solute concentration, and this osmotic loss of the water causes the plasmolysis or shrinkage of the cell's cytoplasm. Let's see in the figure. You can see in the first chart plasma membrane cell which is present into the solute concentration, and the solute concentration that is very isotonic solution, that is NaCl concentration is 0.85%, and you can see the that is the osmotic effect. There is no osmotic effect. Cells will grow very normally, very easily. But in the second graph you can see the solute concentration will be increased up to 10%, and the plasma membrane will be shrinkage, cytoplasm will be shrinkage, and water will be passed out from the cell to the outer environment. Environmental factors and growth. First of all, osmotic effect and water activity. Organisms which thrive in the high solute concentration, that is known as osmophile. If the organisms which tolerate the high solute environment, it is known as osmotolerant. If the organisms which thrive very well, which grow very well, that is known as osmophile. And if the organisms which survive, which tolerate the high solute environment, it is known as osmotolerant. Organisms which thrive in high salt concentration, that is halophile. If the organisms which tolerate high salt concentration, that is halotolerant. Organisms which thrive in high pressure, it's known as barophile, and if organisms which tolerate high pressure, that is barotolerant. Halophile and related organisms. In the nature, osmotic effects are of the interest mainly inhabited with high salt environment that reduce the water availability. Salt concentration and without NaCl, microorganisms growth it's impossible. But high salt environment, microbial metabolic activity, microbial organisms growth will be stopped. Halophile had evolved to grow best at reduce the water potential, and some extreme halophile, example that is halobacterium, and require the high level of the salt for the growth. Halotolerant can tolerate some reduction in water activity of the environment, but generally grow best at the absence of the added solute. And xerophile able to grow in very dry environment. There is a graph of the growth rate against the NaCl. You can see halotolerant, halophile and extreme halophile. Halotolerant, that means ki 0 to 15 to 16 degrees Celsius, for example Staphylococcus aureus. Halophile, Vibrio fischeri, that can grow at the optimum in the presence of the salt concentration, and extreme halophile which need for the growth extreme matlab ki high salt concentration. And there is a non-halophile, that is E. coli. They do not need any salt concentration, they can grow isotonic environment. Thank you.